Hello everyone. So today we are going to solve this LeetCode question, which is divide an array into subarray with minimum cost part 2. Part we have seen yesterday, part 1. It is almost similar to that problem. Just in yesterday we have to divide our array into three contiguous arrays, okay, in part 1. But here what is given, it is given an integer k and we have to divide our array into k subarrays, okay, and the cost of the subarray is same, which is the first element of the subarray. Cost part is same. What else it is given? It is given a distance variable, which is says the difference between, that is the distance between the second subarray and the last subarray should be the less than equal to distance. Okay, so what is it's given, uh, less than equal to distance. Okay. Okay, got it. So let's see with this example what it says. It says we have been given 1, 3, 2, 6, 4, and 2. Our k is 3 and our distance is 3. Okay. So the first sub array will always be starting from the first index. No doubt about it. Now our second sub array can start from here. That is the third position. Okay. And our k should be equal than 3. So this is 0, 1, 2, 3, 4, and 5. So our second sub array can start from here and it can go till here, because 4 minus 1 this is equals to 3. So it should be equal or less than 3. But if we would have taken this one also, then it would be 5 minus 1, which is equal to 4, which is obviously greater than our distance. So we will not consider it. Okay. So this is simple. Okay. Now this now what we have to find, we always we have to find the k contiguous arrays. One has always been already been found. Now we are left between k minus 1. So in this window we need to find k minus 1 smallest elements. K minus 1 smallest elements. What would be that? We can sort this. So it would be 3, 2, 3, 4, and 6. Now k minus 1 are 2 are left. So we'll take these two. Its sum is 5. Now we can move our window from here to here, because here the distance is also 3. Okay. Now what, we'll sort again these numbers. Here after sorting, what are will be the numbers? 2, 2, 6, and 4. Okay. Here sum of smallest are 4, which is obviously less than 5. So we will go this as our final answer. Okay. So what would be our arrays? 1, comma 3, then 2, 6, and 4, and 2. Dividing our nums array into these three contiguous arrays, and the cost here is 1, 2, 1, 2, which is finally is 5. Okay. Here was 4. Will consider, we'll have to add first position always also. So it would be finally be 5. Okay. So the problem is that whatever our array nums is given, okay, we have to start from the first index and go till distance minus first index. Okay, suppose this was ith index, distance minus ith index, and we will have to find the k minus 1 smallest element in this window. Then we'll move this window one at a time, and in each window we'll find these k minus 1 smallest elements. And in whichever window this k minus smallest element sum is minimum, we'll go with that window and include the first index in our answer, and that would be our final answer. Okay, so now let's see with the help of code how we'll solve this. Okay, so we can define a custom data structure, okay, which will help us to maintain the smallest k elements. Okay, what we'll define in this data structure is int k, which would be our number of the small elements to track. Okay, that is our k minus 1 elements we have to track. Okay, small numbers. Then we'll define a multi-set. Okay, we, low will store the k smallest elements and high will store the remaining number of elements. Okay, then we'll define these sum of low elements. Okay, then we can have a constructor which will initialize our k smallest elements. Okay, then we have a method to find our window size, which will initially be starting from the first element to distance minus first element, which is return low dot size plus int of high dot size. Okay, this will return the total number of elements in our current window. Okay, now what we have to do, we have to define a method in which we rebalance it. Means when we are shifting the window, we have to remove one element at a time and include one element. These two operations have to be done when we are shifting any window. Okay, so this will we do, which is we'll define a variable, okay, in which we have only need minimum number of k elements and the window of size. Now what we'll do, while low dot size is greater than mean, then what we'll do, if low has too many elements, we'll remove them and move it to high. We'll take an iterator. Okay, we'll erase this we'll remove it from our sum also. and we'll insert in into high. Okay. Then what we'll do, we'll check if low dot size is less than need, and if our high is not empty, then what we'll do, that is low has very few elements, then what we'll do, we'll move the elements from high to low. Okay, that is the opposite what we have done. Okay, and means if low has many elements, we'll move from uh, low to high, and if high has more elements, then we'll move from high to low. Okay, and why we are doing it, we are doing it to find the smallest k elements. Okay, then what we have to do, we'll define a method which is void of add, in which we'll add the elements in our low and high. That is if low dot empty, or if x is less than equal to previous of low dot n, then low dot insert x. Else what we'll do, high, else we'll do high dot insert x, and then we'll call that rebalance method. Okay, now we'll define our method to remove the elements. We are just making tools so that our final sliding window would be easily. Okay, here we send the element which we have to remove. Okay, simply we'll find that in our low and erase it from our low multi set. Okay, then we'll remove it from the sum also. Else what we'll do, else we'll high dot erase it off high. Okay, then what we'll do, we have define it, then we'll rebalance it again. Okay, finally what we'll do, we'll return the query sum, long query const, it will return the low, which is like sum of k smallest elements. Okay, finally this was our data structure. Now what we'll do in our main method, in our main method what was given, the nums array was given, the k variable was given, which is the number of subarrays in which we have to divide, and the distance. Okay, Then what we'll do, we'll simply define a variable in which first we store nums.size. Then obviously our counter was initially -1 because 0 index will always be there. Then we'll call our smart window data structure which we have defined. It's window which will give us k number of windows. Okay, that is we have to find the k small elements. By suppose k was 3 minus 1 we have already done because for 1 we already have, that is the 0th index of num. Okay, then we'll iterate through 1 till 1 plus distance. Okay, this will be our first window. Okay, simply we'll window dot add nums of I. Then we'll take a variable in which we'll store our answer, which will be window dot query, as query was returning the smallest k elements. Now what we'll do, we'll iterate from 2 till I plus distance is less than n I plus plus. What will it do? It will iterate through all the remaining windows. Okay, simply how we'll window dot remove, we'll remove one element which is I minus 1, and we'll add the other element which is nums of I plus distance. Okay, and we have already written the code how we'll add, how we'll remove, and in our answer would be minimum of our answer, which was the first Windows answer, and window dot query, which will give us the return the minimum sum of the remaining windows. After iterating through all the windows in the our nums array, we'll have minimum in answer. We'll add the first element in it, and that would be our final answer. Okay, this would be our final answer. So this was how we have solved this problem using sliding window and a multi-set data structure in which we have defined the functions to rebalance, add, remove, and query. Okay, and using these we have solved our sliding window, maintained our sliding window, and we got our answer. So if you have any doubts or suggestions, just put it in the comment section and keep learning.